get this started here. So when we look at this here, we're really continuing on with what we did yesterday with our subtractions, or adding and subtracting. And again, the numerators are not going to change. We're not going to factor, we're not going to do anything to them here because, well, if we factored them, we would have to undo it to be able to add the 2 or subtract the 2 here together. But we do need to factor the denominator so we can see what we need to make them be, how to get them to be the same. Now we look at x squared minus 3x plus 2. We will have 2 sets of parentheses. Because the 2 is positive, the signs will be the same, and they're both going to be negative because the middle term is negative. Now the factors of x squared are going to be what? X and x. The factors of 2 would be 1 and 2. So we get x minus 1 times x plus 2. X minus 2. X minus 1 and x minus 2 would be the factors for this here, and that is factored completely. Now we need to look at the denominator of the other fraction, so we have 2x minus 4. We can factor out a 2, which would leave us with x minus 2. So we have this here. And because, the reason we're factoring the denominators is so that we can see what we need to multiply each fraction by to get them to be the same. Because if I can get them to be the exact same, then we can add or subtract them from each other. So if we look at the one on the left, what does it have that the one on the right doesn't? X minus 1. Because the one on the left it has x minus 1 and x minus 2. Those are the 2 things it has. Well, the one on the right has an x minus 2. It doesn't have the x minus 1. So we're going to multiply it by x minus 1 so that they can be the same. Now we're going to go the other direction. What does the one on the right have that the one on the left doesn't? Well, 2. So we're going to multiply it by 2 over 2. Try to make them be the same. And I think this is a little bit easier than writing x minus 1 times x minus 2 and 2 times x minus 2 on the side and using the least common multiple to figure out what it is. It's a little bit easier if we can just look at it and see this one needs this and this one needs that. Okay. Now that we have the denominators the exact same, so we multiply. So we have 2 times x minus 1 times x minus 2. Minus 2 times x minus 1 times x minus 2. Because the denominators are going to be the exact same. Now the numerators we do have to multiply through. So we're going to have to do 2 times 5x and 2 times negative 1. Well, 2 times 5x is 10x. 2 times negative 1 is negative 2. Scroll up a little bit. Now here we are going to have to distribute through. So we're going to do negative 2 times x, which will give us negative 2x squared. We'll have to do negative 2 times negative 1, which would be plus 2x. And negative 1 times x would give us negative x. And then negative 1 times negative 1 would give us plus 1. So when we multiply this through, we get negative 2x squared plus 2x minus x plus 1. Any questions on how we got to this point here? Or any questions on any of this here so far? We good with this here? Okay. Well, now we can combine some like terms. Over here, because 2x minus x will just give us plus x. And everything else stays the same. So the negative or 2x minus x, we can combine those because they are like terms, so they will go together. Any other questions on any of this here? Okay. Now, at this point here, there's two different routes we can go, and this is really going to depend on your own personal choice. Now, if you feel confident about this, in that I can see, okay, I'm going to change everything up here. The signs for that second part are going to change because we're subtracting it. The negative is going to change the sign of everything on top. So a negative and the negative 2x would become positive. So it'd be plus 2x squared. A negative and a positive make it minus x and then minus 1. So if you feel comfortable with doing that and being able to flip those signs, you can do that there. Now, if you're not as comfortable with flipping it and making sure that that went the way it's supposed to, you don't have to do it that way. Because what we can do is do negative and have both of these in parentheses, and then drop the parentheses and apply that negative. So if you don't feel as comfortable just switching from one step to the next, write it with parentheses and then change it. If we can write it this way, and then I can drop those parentheses and change the signs of the second. Okay. We're almost done. The last thing we need to do is combine like terms and factor, if possible. So any questions on this here? Very similar to what we did yesterday. So we have 2x squared. 10x minus x is going to be plus 9x. And negative 2 minus 1 is negative 3. Over 2 times x minus 1 times x minus 2. And that's it here. And there's no real way to factor this, so using 2 and 3 to get to 9, it just won't work. So this is as far as we can take this here. Now, there are no restrictions for this here because nothing's simplified out of the numerator or denominator. So all of our restrictions that exist are still listed. So we're not really adding anything to this. Questions on this here? Are we good with this here? Yes? Yeah, no. I mean, we could do this here, but really, what we would be doing is I'd multiply this by 4x over 4x. This one by 7 over 7. Is to get 28x over 4x and 21, which would give us negative 4x plus 21 over 28x. And that'd be it. There's not too much to that one. We'll look at this one here, which I believe is the last problem. No? Yes. There's one more? Okay. We'll have this one here, and we'll see how y'all feel at this point. So when we look at these two here, well, again, we're not doing anything to the numerators. We're not going to factor. We're just going to leave them alone. Now we can look at the denominators. Well, 3x squared is one term. There's no way to simplify it down. That wouldn't be helpful. That would be helpful. So we have that there. So what can we do to the other one? Yes, we can factor out a 3. And if I factor 3 out, 3 factored out of 9x squared would leave me with 3x squared. Minus, if I factor 3 out of 12, I'm left with 4. Okay. And we factor that again. So it's 4 perfect square. And they're being subtracted, yes? So it's a different perfect squares, correct? It's 3 a perfect square. No, so that throws that all off. Because if 3 was a perfect square, then it would work. If this number with x squared was a perfect square, well, 9x squared is a perfect square, yes? Is 12 a perfect square? Well, no, so this is as far as it factors. So the most we could do is factor out of 3. Okay, now we need to make the denominators be the same. Okay, so let's do this here. So what does the one on the left have that the one on the right doesn't? And there is one thing. So here we have 3x squared here. So we do have a 3, yes? And this one has the 3x squared minus 4. So what does this have? It doesn't have an x squared. Now the one on the right does have an x squared, but it's what? 3x squared minus 4. All of those are stuck together. This is a term. So this x squared is actually different from this one here. They're different terms completely. And the main reason that is because the one on the right is being multiplied by 3 and then subtracted by 4. The other one is just by itself. So those are going to be considered two different things. Now if we go the other direction, what does the one on the right have that the one on the left doesn't? Yes. It has that whole term. So the denominators don't change because they're going to be the same, because, well, we can't do anything if they aren't. Now we can multiply the numerators. Well, 3x squared minus 4 times 1 as well. 3x squared minus 4. Over here we have x times x squared, which is what? X cubed. Well, now we can add, yes? And according to number theory, we would have x cubed plus 3x squared minus 4. And I'm going to go on and tell you this is as simplified as it gets. Because for us to really factor that numerator, we need one more term. Because I need an x term, a term with x to the first power, really to possibly be able to factor this. But this here is as simplified as it gets. Because the only other way we can rewrite it is if I broke it up into individual terms, which really isn't making it simpler. It's making it into 3 fractions instead of 1, which doesn't help us as much. And that's it. That's all we have to do for this here. Questions on this here? All right. I'll draw a blue line.